In this set, we're going to look at hybrid functions, which the book also calls piecewise functions. Piecewise just means they're made up of separate pieces. Hybrid, if you do biology, you probably know it's made up or combined of multiple things. So a hybrid function has two or more parts. Here's an example of a hybrid function. This one has 3 parts, and you'll notice that I've specified a domain for each section. All right, so the first section is a negative linear graph only when x is less than 0. The second section is a positive linear graph when x is between 0 and 1. And the third section is a slightly less steep linear graph only when x is bigger than 1. All right. This is an example of what it looks like. Here's section 1 when x is less than 0. Here's section 2 in the blue when x is between 0 and 1. And here's section 3 in the green when x is bigger than 1. You'll notice that at each point, at each joint, it has a sharp point. Hybrid functions are particularly useful when a set of data doesn't match one particular model. For instance, this set of data doesn't match one linear model. It has a negative one, a steep positive, and a slightly less steep positive one. So this is particularly useful. Now what we can do, or what we have to do, is we're going to actually look at the domain. We can easily see that x is a subset of all real numbers. However, we do have to take into account the domains of the 3 individual parts, and in particular look at the meeting points of the parts. So this one here, first part, ends at 0, and the second part begins at 0. Now you notice that 0 is equal to x in the second part, but not equal to x in the first part. And the same at the other end, x is equal to 1 at the end of the second part, and x is greater than 1, but not equal to, at the beginning of the third part. This means that the points 0, when x equals 0, and x equals 1 are included in the graph. And I will show you another example of what it looks like when they're not included later on. We'll also look at the range of these graphs, and you can clearly see here that the range, the most negative y value is negative 1. So it goes from negative 1 all the way to infinity in the positive direction. The value is undefined. Now here's an example of a function that doesn't include a value, a hybrid function that doesn't include a value. You can see here this is g of x is made up of 2 parts, x squared when x is greater than 0, and negative x when x is less than 0. Notice that 0 is not equal to x at any point. What this looks like is this. We have the quadratic section where x is greater than 0, and the linear section where x is less than 0. And if you look here at the point where they meet, you can see that it has a hollow dot. Now we know that hollow dots mean that the value is not included, and Desmos actually tells you the y value is undefined on the linear side. That's why the dot is surrounded by a purple outline. Over here, you can see the dot is surrounded by an orange outline, which means we're working on the quadratic section, and Desmos also tells you that. All right, this means that 0 is not included in either section of the hybrid function. So to put this one's domain down, we would say that x is a subset of real numbers excluding, that's a terrible curly bracket, 0. All right, this means that x is everything apart from 0. The range of this function we can clearly see goes from 0 is not included as well, so we can't say that 0 is the smallest y value, which means we're going to go for r positive. It's all the positive values. We should know that 0 is not technically a positive number, so therefore it's not included. So there we have it, the domain of a hybrid function not including a point, and the range of a hybrid function not including a value. All right, back up here, g of x equals x squared when x is greater than 0, negative x when x is less than 0, as shown by the Desmos function. All right, it's very important that when you see these hybrid functions, you study the domains carefully, particularly the points where the different parts meet, as this will tell you whether or not to include these values in your interval notation or set notation for the domain.